Well, in reality, what we'll find is that the shortest distance between any two places on planet Earth is an angle subtended at the centre of a circle. Now, I've just drawn A to B on an apple, the north-south line of longitude, the equator there. If I take a slice through, you can see that this will go through the centre of the apple, the centre of the planet. The smallest distance between the two will form a radius exactly the same as 6371, the radius of the Earth, and I can then find that providing I know the angle subtended. The angle subtended at the centre of the planet is found using quite a complex little formula. Cos theta is sine of latitude P times latitude Q plus cos of latitude P times latitude Q times the cos of the longitudinal difference. Now, in order to find the longitudinal difference, the key thing is to make sure that you draw a planar view. So in other words, looking at the North Pole view and taking a slice through. That way, both places will be comparable for longitudinal difference calculation. The thing to watch out for is that all latitudes in the southern hemisphere are minus or negative. Now, looking at question 39, what we tend to do, we tend to draw a North Pole view. So planar view looking over the top at the North Pole, so I'm able to compare and find the longitudinal difference between Auckland and then New York. Now you can see here that the distance there, if I was flying from Auckland east to New York City, across the Pacific and through, would find the much quicker or shorter of the two distances. As a bit of a check, if I added them together, you would see I'd have 175 and 74, which is 249 degrees, which is obviously too big. So the longitudinal difference in this case is probably best found by getting 360 and then taking from that the addition of the two longitudes. And that will give us 111 degrees. With that information, I can put into the cos theta formula and find the theta subtended at the centre of the planet. So cos theta, sine lat P, sine lat Q, plus cos lat P, cos lat Q, times the cos of the longitudinal difference. Now it's quite a long formula. Now it doesn't matter what you call P and Q. The key thing is though is to make sure that the Auckland 35 appears as a negative. So sine of negative 35 times the sine of 42 and then cos negative 35 times the cos of 42 times the cos of 111, which we decided was the longitudinal difference. Now, showing you how to do that on the calculator, because it is quite a lengthy process and one that you will have to practice. So I've got sine negative 35 times sine 42 plus cos negative 35 times cos of 42 times the cos of 111 equals, and I'm going to keep all the decimal places, and cos to the minus 1 to undo that. I end up with 127.0 degrees. Because that's the angle subtended at the centre of the planet, I can put that into d is equal to 2 pi r theta on 360. and the theta is 127. And I end up with 14,123 kilometers.